Here in this session, we'll be addressing how to solve simultaneous equations by using a new strategy called substitution. At this point, we have already solved simultaneous equations by using the addition and the subtraction method. Here we're going to introduce substitution. And as the term indicates, substitution means that you're going to take one particular value for a variable in one of your equations, and you're going to substitute that back into the other equation. And what that'll help do is it'll eliminate a variable, and then we can then solve that equation for the one remaining variable, and then that'll get us on our process for determining what the values for x and y would be. Well, let's take a look here. We have two equations. We have 4x minus 2y equals 10, and x minus y equals 4. In order to solve by substitution, we need to take one of our two equations and solve that equation for either the x all by itself on one side of the equation or the y all by itself on one side of the equation. It doesn't matter. And that variable that's all by itself does not have any constant that it's being multiplied by other than the number 1. And the number 1 is usually not written, it's just implied. So what do I mean by that? Well, 1x is just the same thing as x. 1y is the same thing as y. But in those situations, we normally drop the 1 and just leave x or y. Well, if we take a look here at our second equation, we're almost already there. We have an x term that has no constant being multiplied by it. We have a y term with no other constant other than 1 being multiplied by it. So we could pretty quickly solve this second equation here in terms of one of these two variables. Well, we have a minus with our y, and we have a positive with our x. So I think it'll be a little bit simpler to go ahead and solve it for x, since it already has a positive value, or I should say a positive sign before it. X itself can be positive or negative, but there's no subtraction sign in front of the x. Therefore, we'll go ahead and solve it for x. Well, right now the x term has a y term being subtracted from it. So in order to undo that, we need to add a y term to both sides. What then is x minus y plus y? Well, the minus y and plus y cancel out to 0. X minus 0 is x. That's what we're left with on the left-hand side. And then on the right-hand side, we simply have 4 plus y. So this second equation has now been rewritten as another equivalent equation, being x equals 4 plus y. What this tells us is that the value for x is the same as the value for 4 plus y. They're identical. Well, how does this help us? Well, how it helps us is that we can actually take this value for x down here, 4 plus y, and substitute it back into our first equation for the x term up here, and then solve this for y. So let's go ahead and do that. We are told by our equivalent equations down here that x is the same thing as 4 plus y. They have the same value. So let's come back up to our original equation. We have 4 times x. Well, what is x the same thing as? The x is the same thing as 4 plus y. Next, we have a minus 2y. Then on the right-hand side of the equation, we have a 10. How has that helped us? Well, how it's helped us is that now our equation up here, equation number 1, only has one variable left in it, the variable y. And we can now solve this for y. Let's use our distributive property. 4 times 4, 16. 4 times y is 4y. That takes care of this. That also leaves us with a minus 2y and then a 10 on the right. If we combine terms, there's no other constant on the left-hand side that is being added or subtracted with 16. So 16 stays there. And then we take the 4y and the 2y and combine them. What is 4y minus 2y? Well, it's plus 2y. So on the left-hand side, we now have 16 plus 2y, and on the right-hand side, we have 10. Next, our y term is being added with a 16. So in order to undo that, we need to subtract 16 from both sides. 16 plus 2y minus 16, the 16's cancel. we're left with 2y on the left, and then on the right, 10 minus 16 is minus 6. Lastly, on the left, our y is being multiplied by 2, so to undo that, we're going to divide by 2, both sides. We are now left with y on the left-hand side and minus 3 on the right. So we've now found that minus 3 is the value for y that'll work in both equations. Now we simply take this and stick it back into one of the equations to find out what our x value is. Let's take a look at our second equation here. We have x minus y. Well, y is minus 3, so we have x minus a minus 3, and that equals 4. Well, remember, minus a minus is the same thing as adding a positive. So what this really is saying is x plus 3 equals 4. So what does x equal? 1. Because 1 plus 3 is 4. So 1 is x minus a minus 3. 1 minus a minus 3 is the same thing as a positive 4 on the left, which equals a positive 4 on the right. Well, let's stick our values into the first equation and see if they match. 4 times 1 is positive 4. 2 times negative 3 is minus 6. So what we have here is 4 minus a minus 6, which is the same thing as 4 plus 6. 4 plus 6 equals 10, and 10 does in fact equal 10. In solving by substitution, as a quick reminder, we are simply rewriting one of the equations here in terms of either x or y, and what that means is that the x or the y will be all by itself on one side of the equation. Once we've done that, which is what we had down here at this step, x equals 4 plus y, we then take that value for x, 4 plus y being the same thing as x, and substitute it back into the other equation that was not rewritten. Once we substitute it back in, we then solve that equation for the remaining variable. And then once we get the value for that remaining variable, we plug that back into one of the equations to find out what the other remaining variable is. That then is a quick overlook of substitution to solve simultaneous equations.